Hi everyone. So good morning, and we are back into our session. So this is going to be lecture number 20 on probability and statistics. Okay, so today we are going to learn how to compute normal probability, right? And we'll also go for some other concepts. So I think many of you might have understood this. How do we compute normal probability, right? In the last session, how to convert any you can say any normal random variable to standard normal random variable that I have discussed, right? So in this lecture, first of all, I will start with the question. One question I'm just going to take, which was asked in gate electronics and communication in gate 2013, right? So let me solve that question, and then you know start computing the normal probability, right? Okay, by converting into standard. So we have to project any normal random variable to uh, standard normal. We have to convert that, and then we can refer the standard normal table, right? Because standard, there is a table which is only meant for standard normal table. Okay, it is not meant for any normal table. Please remember, any random variable. So this is a question. So lecture number 20, and this question was asked in gate 2000, you can say 13, in electronics and communication paper. Okay. So let us solve this question. Okay. So I think this is one of the very important question, and we can see how we can solve this type of question, right? Okay. So we'll solve this question. Understand. So I have informed everybody to join the session, right? Yeah. And 1 minute, let me inform one place as well. Yes. One minute. Fine. So let us solve this question. Okay, I've shared everywhere. So this question, I think anybody can solve it. Okay, if you know, if you just go through this question, right? So what they have given here is, they have given that the u and v are the two independent zero mean Gaussian random variable. Okay, so they have zero mean, but the variance is not going to be equal to 1, right? That you can see 1 by 4 and 1 by 9 is given, and you have to compute the probability, right? You have to compute the probability. So these u and v are Gaussian random variables, right? If they are Gaussian random variable, means they will be having you can say the Gaussian density function, certainly, right? So what you can do here is, you can take this probability, you have to compute the probability, right? So probability of 3v greater than 2u, okay, you have to find. So you can write this as probability of 3v minus 2u greater than 0. Can you write like this? And you can consider this is nothing but a new random variable, okay? The new random variable, you can say z. Z is going to be 3v minus 2u, okay? And this z is, you can say kind of linearly related here, okay? And if v is Gaussian random variable, u is Gaussian random variable, then z is also going to be a Gaussian random variable, okay? U is Gaussian random variable, V is Gaussian random variable, then Z is also going to be a Gaussian random variable, right? So you have to remember that bell-shaped curve, right? And what is the mean of this random variable Z? As long as the mean of U and V is 0, right? So mean of this Z is also going to be 0. Yes, can we say like this? The mean of Z is going to be 3 times the mean of expectation of V minus 2 times the expectation of U. Yes. So as long as the mean is going to be 0 here, the mean of expectation of V and the expectation of U is 0. So the mean of this, new random variable, you can say Z is going to be 0. So what will be the density function? The density function look like this only, guys. This is nothing but a density function for random variable Z. And it is going to be mu equal to 0, right? The mean, okay, expectation of G is going to be 0 here, right? This G axis. Okay, so what they are asking is, in the question, if you look at, they are asking probability of Z greater than or equal to 0. Or you can say that the probability of Z, 1 minus, you can also write this as 1 minus the probability of Z less than 0. Okay, so by looking at the Gaussian distribution, right, what is Z less than 0? This is the, okay, and this is nothing but 1 by 2, you can say. Understand? So the 1 minus, you can say 1 by 2, which is nothing but 1 by 2. Okay. So answer for this question will be B. So I think, okay, I think you guys can solve this kind of question nicely, right? And you will not take much time. So now you may be thinking, sir, why we did not use the information about variance? इसमें हम लोग variance का information use ही नहीं कर रहे हैं, right? Because variance talks about spread, okay? It is not going to be telling you any sort of symmetry kind of thing, right? Okay. So as long as u and v are Gaussian, okay? As long as u and v are Gaussian, understand? So you can say that your new random variable Z is also going to be Gaussian, and you have to compute mean. As long as this v and u are having 0 mean, okay? So your Z will also be having 0 mean, and simple answer is there, you see. Okay. So this is nothing but the probability of G less than 0 or greater than 0, whatever you say, is going to be 1 by 2 because of symmetry. So answer for this question is 1 by 2, and this question was for 2 mark. Okay, you can see these are the options, and for this question these informations are irrelevant. Okay, but you can compute the variance of Z also. Let me compute here. See, Z is given as 3v minus 4u, I think, yeah, 3v minus 2u, 3v minus 2u, yeah. Now what is variance of G? Since these two random variables are independent to each other, right? So you can compute, you can add the variance, right? So here 3 will come out, so it will be 9, the variance of V, and this is 4, the variance of U. Okay. Now 9 into variance of V is given as 1 by 9, I believe. I think, yeah. Can we check that? Variance of V 1 by 9 and variance of U 1 by 4. Okay. They have given in such a way that 1 plus 1, which is 2. So you got the variance as 2. So nothing is going to happen, right? In this question, they are asking to compute the probability. Okay. Okay. So you have to find the area under the density function, under the Gaussian density function. Okay, area under the Gaussian density function. Please remember these points. Okay. Area under the Gaussian density function. Please do remember these points, guys. Fine. So this was the question, and this question was asked in gate 26. If you look at other question also, if you look at PYQ, you will find many questions from normal probability. Okay. Let us move and try to summarize whatever we have discussed in the last session, right? So I'm just going to summarize everything related to normal random variable. Okay. So as you can see here, these are the summary, okay, that you have to remember. Okay. You see, this is nothing but a normal random variable. I'm not talking about standard normal. अगर आप standard normal की बात करते हैं, standard normal की, then you have to write this as 0 and 1. Okay, this is nothing but a conversion, right? You have to convert, you have to make projection from any normal to standard norm. So this is the notation where this guy represents expectation and this guy represents variance. Okay, understand? And a common naturally occurring distribution. Okay, this is naturally occurring distribution. Okay, naturally occurring distribution. If you add many independent random variables, you're going to get the normal distribution only, guys, right? Okay, in statistics, in central limit theorem, okay, remember this plays an important role. And then you have to remember the parameters. So parameter concern is mean, variance. These are the two parameters which is very important. So whenever question will be asked based on normal distribution or normal random variable, so in the question they will be always describing these two parameters, mean and the variance. Suppose mean is not given and they said that it is a standard random variable, so you have to consider the mean as 0 and the variance as 1. Okay, so these are the some implicit assumptions that you have to make. Okay, and support is gonna be entire real line. Okay, entire real line. Okay, see, if you look at this kind of situation, so this entire real line is gonna be the support, and the PDF looks like this. Okay, this is the PDF. Okay, for normal random variable, and this is nothing but your CDF. Okay, this is CDF. Understand? And CDF, you know how to convert. This is nothing but your standard normal, right? This CDF is basically where phi is the CDF of standard normal. Okay, where phi is the CDF of standard normal, and expectation is nothing but mu, and variance is gonna be this. So what I said was, in the last session I told you also that if standard deviation is gonna be high, large, okay, so spread is going to be large, and if standard deviation is lesser, right, so spread is gonna be lesser, right? So I can show you these two curve. You can just focus on these two curve. These two curve you can see, that's it. Okay, ये एक हो गया, एक ये blue, and these two color you can see. Okay, and I have also talked about linear transformation, right? So you can just remember that, just giving you the recap of last session, whatever we have discussed. Okay, linear transformation, if x is any normal, it has mu and sigma. So bi is the linear transform of x such that bi is given like this. So if you want to find expectation of bi and variance of bi, the expectation of bi is going to be a mu plus b, and variance is going to be a square sigma square. You know how to find that. I need not to discuss this. Okay. Now how to convert any standard normal, any normal to standard normal, right? So that we can also see here, right? So projecting the standard normal into, projecting any normal to standard normal, right? You read this. So here they have used W, you can take Z also, no problem. This can also be written as Z. The Z equal to x minus mu y sigma. Okay. So notations are, it's okay, right? If you understand things, notations are okay, fine. You can use it. Okay. In the gate, they can give you any sort of notation. So if you look at this, how to project any normal to standard normal. अभी आप देखो, if you have watched my past sessions, previous session, then life is very simple. Okay, so you can read it for any normal random variable x. It is not standard normal. We can find linear transformation from the x to standard normal. Okay. Okay. Note that the z is a typical notation choice for standard normal. Okay. Z. Okay. In the book also you will find z. Z is gonna be x minus mu y sigma. and we call it, you know, in statistics. Okay, sometimes I'm not able to pronounce statistics also in my, you know, undergrad days. In fact, in MTech days also, like, uh, I was not able to pronounce, this kind of notations. Okay, like, okay, statistics. Okay, this kind of problem happens, right? If you are learning something in pure Hindi, if you're from Hindi background, okay. So for any, you see, note that Z is a typical notation, choice for standard normal. For any normal, if you subtract, remember this, okay? These steps I have told you, right? So if you subtract mean of the normal, okay, and divide by the standard deviation, the result is always standard normal. One of the very important, we can prove mathematically, right? So you can say W is nothing but this. What is the proof, guys? I can just give you the proof. I have given last time also, and I will give you directly. Okay? Each and every step is mentioned also. Suppose you have got W equal to X minus mu by sigma. Okay, that is nothing but standard normal. So this is the first step. Okay, like to convert any random variable, okay, any normal random variable to, let's say, X minus mu by sigma, you can write. Okay, so this is nothing but a transform of X. You have to transform the X, subtract mu and divide by sigma. This is the first step. And then use algebra to rewrite the equation. You can rewrite like this. And linear transformation, okay, where A is nothing but 1 by mu, B is nothing but this. So you can find the mean and the variance. So this is the mean and this is the variance. Okay, the linear transformation of normal is another normal. Okay, ये बहुत important statement है. Linear transformation of normal is another normal, you have to say, right? It is nothing but, y equal to ax plus b kind of scenario. Okay, they are related by the straight line equation, and now you can find out mean and this, so you will get this. And I have given a very simple way of finding mean and mu. So very simple. Okay, it is detailed proof. Okay, so if you have got, if you have got the standard normal, right, so you can go for what? You can go for CDF. Okay, you can go for CDF. So suppose you know that X is a random variable, right? X is a random variable which has mean, mu and sigma square, the variance. Okay, okay. Now if you want to convert into G, so it has some sort of, you can say, CDF, right? But this CDF is quite difficult. It does not have any closed form. Okay, if you want to compute this CDF, cumulative distribution function, right, it will be very difficult, understand? So what we can do here is we can project this X into standard normal. तो आप क्या करोगे? Z निकालोगे. Z is nothing but X minus mu by sigma. Okay, now in place of X you can put, okay, in place of X, right, in place of X you can put this value, right? I mean, okay, so let me do something, some smart trick. Let us play. Okay, so suppose you know that by definition, right, f of X equal to probability of X is less than X, right? So if you want to convert into standard normal, so what you will do? You will subtract X minus mu by sigma, and here also you have to subtract both sides. You have to do the same thing, right? So small x minus mu by sigma. Now what is this, guys? ये क्या है? This is nothing but a standard normal. So you can say that G is less than x minus mu by sigma. Okay, and this is defined as phi of x minus mu by sigma. Okay, this is f of x. I think this is clear, right? Okay, So we can now refer the standard table, right? Okay. See, as long as this is a normal random variable, so these things will be given always in the question, right? These two information will always be given in the question, so you don't have to worry about this. ठीक है, ये आप याद रखना जो मैंने अभी बता दिया. यूजिंग द ट्रांसफॉर्म वी कैन एक्सप्रेस एफ ऑफ एक्स, द सी डी एफ ऑफ एक्स इन टर्म्स ऑफ नोन सी डी एफ ऑफ जी. क्योंकि आपको सी डी एफ ऑफ जी पता है, बट यू वांट टू एक्सप्रेस दिस गाय इन टर्म्स ऑफ, ओके. सो ये स्टेप है. सो द वैल्यू ऑफ दिस phi of x can be looked up in the table. Every modern programming language also has the ability to calculate the CDF of normal random variable, right? So if you're from computer science and if you're from so you can go for computer programming and all, but you know, in the gate examination there will not be any sort of you know, coding challenge or something, right? You have to compute everything, you know, manually. Fine. So this is the idea that I wanted to discuss. So let me take one question here. Problem number 1. I mean, so what is the first? If I ask you the computing the normal probabilities, computing normal probabilities. So first step is gonna be what? What is the first step? You have to express an event of interest in terms of standard normal. That is the first step. Express the event of interest into standard normal search in terms of standard normal. Now you may be thinking, sir, in ये event क्या है? अरे whatever inequality, whatever inside that probability of something, that is event only. So any random variable you can take, which is taking some values, right? Greater, equal, okay? They are event only, right? So express the event of interest in terms of standard normal. In terms of standard normal, right? So let me take one question. I mean, just to explain you. Suppose you have got, suppose any random variable is given, which is not a, you know, standard normal, and having the mean 6 and the variance 4, right? So here you can say that the mean is 6 and the variance is 4. So what is standard deviation? Which is 2, right? These are the things which is given. Okay. But now what they are asking is like, you know, if you have to compute, suppose they are asking, if you have to compute probability of 2 less than x less than you can say 8, they are asking this value. So how that idea will come into picture? You have to convert into standard normal, because once you will look at the mean and the variance, okay, you cannot find out the probability directly. That is the first intuition that you have to bring in your mind, okay? जैसे x यहाँ पर दिया हुआ है, राइट? अब कैसे आपको पता चलेगा कि you have to convert into standard normal? जब आप धीरज सर की क्लास अटेंड कर लोगे तब, वैसे नहीं. If you look at, you know, any notes which are available online for, you know, चाहे वो टॉपर की नोट्स क्यों ना हो, ठीक है, formula sheet, whatever, right? You will find that they have written also in the short note whatever coaching centers has taught, like, you know, some point which you have to mug up, but that is not the proper way of learning. You know, any problem is given, that should strike in your mind. अच्छा, यहाँ पर ऐसे ऐसे करना है, आंसर आना चाहिए, मतलब, okay, लाइफ में ऐसा सीखो, okay? So here x is any random variable and whose mean and variance is given, which are not standard, right? 0 and 1. Now you have to find probability of random variable x which lies between 2 and 8, right? So what we can do here is we can convert into standard normal. So how to convert, right? Remember this. The probability of 2 less than x less than 8. So convert आप कैसे करेंगे? First you have to subtract whatever like 2x and 8, right? So you can write this as uh, x minus mu. Mu is nothing but 6 and variance is 2. Here also you can say 2 minus, okay? Because after all you are subtracting here and dividing. So 2 minus 6 by 2, and this is 8 minus 6 by 2, right? So now this becomes C. They are asking you to compute the probability of this, right? But now you are changing you are expressing this event, whatever event is there, to standard normal, guys. And this is nothing but your G, guys. Okay, so you can replace this guy. This, if you solve this, so 2 minus 6 by 2, मतलब कितना आ जाएगा? Minus 4 by 2, that is minus 2. And this is G. And ये कितना आ जाएगा? 1 आ जाएगा, I think, yeah? Yeah. So this is nothing but a standard normal, right? So you can now refer standard normal table, right? So you can say that this is going to be fg1 minus fg minus 2. Okay, yes, I think this is clear, right? So you can write like this. Okay, so we can say that fg1 minus fg minus 2, or you can also write this as 5 1 minus 5 minus 2, or you can also say like this: probability of g less than 1 minus probability of g less than minus 2. But make sure that you have to convert this guy, okay, because this is negative. Here negative value of random variable is given, so you can write this as 1 minus the probability of what? 1 minus the okay, 1 minus the probability of g less than 2. Okay, very simple. So if you solve this guy, so it will give you g less than 1 minus 1 plus probability of z less than 2. Yeah. So now you can refer the table. From the table you can put all these values and compute it, right? So you will get the answer. Okay. Only where the confusion exists is the confusion exists for negative value of that. Okay. तो आप सिंपल याद रखो बस. What is simple? Simplicity क्या है? You should know this phi of g. That is nothing but probability of g less than. Okay. Understood. Okay. X minus mu by sigma. Okay. Fine. So let me take one more question here. Same, right? First example. Okay, this I have taken this example from Stanford Online. Okay, so x is not a standard normal, right? So here mu is 3 and variance is 16, right? So deviation is gonna be 4. I mean the standard deviation. Now you have to find probability of x greater than 0, which is very difficult to compute, right? So what you can do here is you can convert this x into standard normal, which is nothing but x minus mu by sigma greater than 0. So which is p of that is g greater than 0, right? Understand? That is g greater than 0. Okay. So but make sure that if you are subtracting or whatever you are doing, you have to do both sides. ये भी एक point था, I need to mention that. So if you're subtracting something, in the so x minus mu is 3 by sigma. So here also you have to subtract. Okay, whatever you do, whatever manipulation you do, both sides you have to execute. 3 by 4, 3 by 4. Okay. So x minus 3 by 4 greater than 0 minus 3 by 4, right? So this is g greater than -3 by 4. Now it is negative, right? So what you can do here is you can say that probability of, you can write this as, let me tell you, 1 minus the probability of g less than minus plus 3 by 4, okay, and 1 minus p 3 by 4. Now you have to refer the table, that is 0.75, and you will get the answer as, okay, I think I should write little bit of, oh yeah, 1 minute, just a wait. ठीक है, हाँ, that 1 minute, that is g greater than, yes, that is greater than, right? Okay, fine, 1 minute. So what we have to do here is, let me write again. Sorry for that. So here what you have to do, you can write this as g greater than minus 3 by 4. Then you can write this as 1 minus the probability of g less than minus 3 by 4, and then 1 minus probability of g less than 3 by 4, right? I think now it is clear. So it will give you phi of 3 by 4 only, right? So you can refer the standard normal table and you will get the answer, right? So I'm just giving you complete solution as well. So this is the solution, right? Yeah. If this kind of example comes, so you can solve it, okay? नेक्स्ट, अगर मान लो तुम्हें ऐसा आता है कि व्हाट इज द प्रोबेबिलिटी दैट, सेम क्वेश्चन बट दे आर आस्किंग प्रोबेबिलिटी x lying between 2 to 5. See, in continuous random variable, equality does not make any sense. Okay, so first of all you have to convert this guy into standard normal. So subtract 2 minus, what was the mean and variance, mean and deviation? 3 and 4. So 2 minus 3 by 4, x minus 3 by 4, 5 minus 3 by 4. Whatever you are doing, you have to do in all the terms. This becomes minus 1 by 4, and this is g. You just replace this guy by g directly, no problem is there, right? You don't have to do anything. Earlier what I used to do here is, when I was taking classes and all, right, when I was the kind of student, you can say, so I used to do all these, then I used to subtract, like I used to only perform all these manipulation on this guy z, and I used to forget these things. तो आंसर ही नहीं आता था, मुझे लगता था ये क्या चल रहा है लाइफ में, राइट? एंड वी नेवर फाउंड आउट दैट सिंस आई स्टार्टेड टीचिंग. So since I wanted to explain you guys, so these things are okay. So 1 by 2 now, okay, understand? So you can say that this guy is going to be this is going to be what, guys? This is going to be your you can say phi of 1 by 2 minus of 1 minus phi of 1 by 4. Okay, so you can write this, okay, by inspection you can write, okay, if you have watched my lectures. So ये बहुत ही simple situations हैं, right? So if you refer the table, you will get this value. Okay, in the exam they will mention the table, right? Don't worry about that. Now let me take one question, right? I mean, this is a question can be asked, okay, in your exam, right? And this is nothing but a communication system based questions, okay, like in the exam they might ask you, okay? And there's a high chances for electronics people, right? In data science also they might ask this kind of question, right? So you need voltage of 2 or minus 2 on the wire to denote as 1 or 0, right? Okay. So whenever you send some signal, you can say, let's say here you're sending 2 volt or minus 2 volt, but you're denoting with the help of 1 or 0 because you are using digital communication. So here the random variable is nothing but voltage sent, right? You can say 1 or 0. Okay. And R is the voltage received. So certainly you're going to send, once you will send your message signal, right? Okay, from transmitter. Okay. So it might happen that in the channel, the noise can get added, right? Certainly it will be added. And what we are considering is we are not receiving X as the, receive signal. We are receiving something which is also got added with the message signal, right? So you can say by is here the noise, right? But now they are saying that by is one of the beautiful thing they have mentioned in the question is by is a standard normal random variable, sir. And in my life, whenever I see standard normal random variable, I really become so happy. You know? So you should be crazy like this, okay, in your life, right? Like whenever we eat something, we become very happy whenever we get something. Suppose we are waiting for iPhone, or we want to get into IIT, we want to do anything, right? Okay, whatever wish we want, if something is coming true, right? So we become happy. So whenever, in my case, whenever I look at the standard normal, I really feel how simple this distribution is, and it makes your life very simple, right? And many students face problem in this kind of a question. So I'm just going to explain this, and I will cover more depth for electronics people in their digital communication course, right? सो देखो, आपको एप्लीकेशन नहीं बताया जाता, आपको डायरेक्टली क्वेश्चन सॉल्व करवाया जाता है, राइट? तो आपको समझ में नहीं आता, ठीक है? तो दिस गाय इज नथिंग बट योर रिसीवर, राइट? Received signal x plus by, and here this is standard normal. So what they are asking is when decoding, right? When you're trying to understand what was sent, basically, if r is greater than 0.5, so this 0.5 you can consider as a threshold voltage. We interpret the voltage is as 1. मतलब आप ऐसा बोल सकते हो कि this is the 0.5. If something is greater, right, you can say x plus by falls in this region, so we say that 1. And if it falls here, it is decoded at 0. Now the question is, what is the probability of error after decoding given that original bit is 1? Suppose you're sending 1, and it is not necessary that you're going to get 1, right? So this is nothing but a probability of error, and here they are asking the conditional probability, right? Okay, understand? So error after decoding means what? If suppose given that the original bit is 1, right? So if you're going to see what is the correct probability, if something lies, if r is greater than, you can say r means if x plus by is greater than 0.5, then you're going to receive 1, right? And if x plus by, you can say, is less than 0.5, you're going to decode it as 0. This is the correct decision, you can say. But what they're asking is error after decoding. There should be error. Error means what? If this is a situation, right, x plus by less than 0.5, okay, then you're going to get 1 here. This is you can say considered as 1, though it should not be considered as 1, right? It is 1. Okay, so we can say they are asking that the probability of x plus by less than 0.5. They are asking this question. Okay, I think you understand from the question itself, yeah? So this is a question they are asking, right? So how to decode this problem, right? And one more thing that you have to remember is pi is a standard normal random variable. So you can take x this side. So 0.5 minus x, okay? 0.5 minus x, okay? And what you have sent, right? Original bit is 1. 1 means in terms of voltage it is 2. In the question it is given, right? You see, it means you are sending 2, but you are receiving what? 0. You're sending original bit is 1, but you're receiving 0, right? That is the error. If you're sending 1, you should get 1, na? See, if you're sending 0, you should get 0. If you're sending 1, you should get 1. But because of this noise, your 1 is becoming 0 and 0 is becoming 1. That is the probability of error. That is the error which is happening in the receiver end. Okay. So by, x is 2, right? So you can say that by less than 0.5 minus 2. So probability of by is less than 1.5, and this is nothing but phi of 1.5. And the answer for this question is, you can say that, right? Okay. I mean, you can understand this. ठीक है, इसको आप कैसे लिखोगे? This is nothing but 1 minus the probability of by. I should write like this. So 1 minus the phi of 1.5. Please remember this. Okay, I made the mistake over there. तो ये आप टेबल आपको दिया रहेगा, and this you can refer from the table. Okay. आप दूसरे तरीके से भी सॉल्व कर सकते हैं. कैसे आप थॉट प्रोसेस कैसे डेवलप करेंगे? As long as, suppose in place of by they have given n is the noise which is standard normal, standard Gaussian random variable, and in communication system language, communication engineering, we call this noise as white Gaussian noise. We call it AWGN, additive white Gaussian noise, guys. Additive white Gaussian noise. It is a random variable only. Why we call it additive? Because this is going to get added with the message signal, okay, whatever you are sending from the transmitter. But make sure that if you are not from electronics background, you are preparing for data science in AI, so needless to worry about what is the meaning of this white and all, right? EC वालों को समझना है, but and for electronics I will cover in digital communication. ठीक है? So n is noise. Suppose you are sending, okay, they have given the decision, right? What decision? I mean, they have given this kind of situation, right? If you're sending something, okay, so VTH is, you can say 1.5. So if you're going to send something, right, it falls in this area, so you will be decoded as 1, and if it is going to fall in this area, right, so it is decoded as 0. Okay. Okay. So what is the meaning of that? You can draw the picture, right? Okay, so if it is a 0 mean Gaussian random variable, right? 0 mean Gaussian random variable, okay? So first of all, by you have to draw. So please draw the by. By अगर आप draw कर रहे हो, the density function you can say for by, that is or for noise, okay? So most of the time in the question, what they will give you is they will give you the density function for noise, right? Because noise is a random variable. If noise is a continuous random variable, then it must be described by the density function. That is very important, okay? For massive signal, they will not give you the density function. Okay? I think you guys are able to understand this fine, yeah? So, so you can say that density function look like this. If as far as this is a Gaussian, you can say that by, okay. Now what we are going to do here is we are going to add the message signal will be added here, right? So new random variable you're going to get. So if you add something here in this standard, you can say normal PDF, if you're going to add these numbers like 2 and minus 2, so what will happen? These guys are going to get shifted. So if you add 2, so it becomes, it will be shifting like this. This is 2. If you're going to add minus 2, so this will be shifting here, minus 2. Now this is nothing but your R, right? R is nothing but x plus y. I think this is clear, right? Okay. So this is a scenario. Understand? Okay. So, but they have mentioned the decision point, right? They have mentioned the decision point by themselves. If they haven't given these threshold point, you can say, so optimum threshold should be here, right? Okay, that is between 2 and minus 2, but they have given something, right? They have given this point, right? That is 1.5. Okay, so if something is greater than 1.5 here, right? So it is decoded as 1, correct? And less, it is decoded at 0, that is okay. But if you're sending 1 and you're receiving 0, that is a question, right? So if what they are saying is if you're sending 1 means you are adding 2 plus the noise, okay? 2 plus the noise, understand? 2 plus the noise. Okay, and I think decision point was what? Let me check that. 0.5, yes, sorry, I should take care of this, right? 0.5. Not 1.5, it was 0.5, right? So you can say it is very close to 0.5 only, right? Yeah. So 2 plus by, okay, you receive 2 plus by. Now you're doing decision, right? Please make the decision here. So 2 plus by, if it is, what, greater or lesser? You have to think, okay, if it is less than 0.5, right? Then only if original bit is 1 and you're going to receive 0 here. Okay. So this is the probability they are asking. Okay. That is the error. Okay. So yeah, 1.5 and इसको तो आप डायरेक्टली कर सकते हैं. Okay. 1 minus 5, 1.5 and then answer. I think this is clear for all, yeah? Now let me take one more question. See, communication system engineer, they will use one important function called Q function, right? वो उनके लिए हम बताएंगे ये Q function क्या होता है, okay? So that they can write probability of error in terms of Q function. आप लोगों को ये जरूरी नहीं है, आपको बस phi पता होना चाहिए, this phi, ठीक है? Now, this is the example, right? So 60% rule of normal within one standard deviation. What is the probability that the normal variable has a value within one standard deviation of its mean? मतलब x minus mu, one standard deviation of its mean. What is the probability that a normal random variable has one standard deviation of its mean? Very good question, right? So can somebody solve this question? कैसे solve करेंगे? So what within one standard deviation of the mean का मतलब क्या होता है? Probability of within one sigma of its mean का मतलब क्या है? What is the meaning of that? That is nothing but your your random variable lies between mu plus sigma. Spread is like this, mu minus sigma. One standard deviation away from the mean, right? Okay, so how can you write this? You can write this as probability of mu plus sigma minus the probability of, oh, I should not write like this. I should write this as probability of x less than mu plus sigma minus the probability of x less than mu minus sigma. Yeah, ठीक है. Okay, this is the probability range. Because of probability range we can find right like this. Yeah, what is this? What is this? It's a very simple situation, right? So you have to first convert this guy into standard normal, right? आपको स्टैंडर्ड नॉर्मल में कन्वर्ट करना पड़ेगा ना. तो हाउ टू कन्वर्ट दिस in standard normal, right? So you can convert, so you can say that phi x is this mu plus sigma minus mu by sigma minus mu minus sigma minus mu upon sigma. So this mu gone, sigma gone, so this is phi 1 minus this is nothing but minus minus 1, phi of 1 and phi of minus 1. So now you can find the values, right? Phi 1 minus phi of minus 1, which is phi 1 minus 1 minus phi 1. ठीक है. So I think 2 phi 1 minus 1. So you can just find out this, right? So yeah, fine. So from the table you have to just find the, let me see that table also. Standard normal table. Yes, 1 minute. I think image standard normal table, right? That is nothing but a Z score only, you can say. Yeah? Let me get that picture. Yeah. Some good picture I can get. So yeah, so we can copy this picture. Copy and we copy and yeah, copy the image. Right. So we have to take phi 1, right? That is g equal to 1. Let me see what value is there. ये g equal to 1 है ना यहाँ पर. क्या वैल्यू है देखो. This. Okay, so that answer is 2 into 0.8413 minus 1. If you solve this guy, right, so I think you can now get the answer, right? So let me solve that also. Calculator. आपको सारा compute करना है, right? So 2 into 0.8413 minus 1, you'll get 0. Something, yeah, 0.683. And this is the correct answer, right? Okay, this is the correct answer for this question. So I have computed everything. I can just put the solution as well in front of you so that you guys can have a look. ये आंसर है. Don't run run away from these calculations, right? These are very important calculations. Okay. So please remember this. ठीक है. And this is done, guys, you have to remember that you have to convert everything into standard normal, right? And then you can compute the probability. I believe this is fine for all. Okay? Yes. So if you look at the PYQ, you will find many questions, and your life will become very simple. Okay? So please watch these sessions. We'll meet in the next session. Thank you for today.